Hi there, welcome to this video. Thanks for clicking on. Hopefully you've done so because you're sitting Maths A Level Edexcel this summer. Here's the list of the advanced information provided by the exam board. I've done a series of videos where I've taken a question from each of these topics and just given you an example walkthrough solution. But in this video, I'm just going to focus on one topic. I'm going to focus on the trigonometry here in paper 1 and the trigonometry here in paper 2. So let's get into the video. So hopefully you're finding things like this video helpful because it is easier to follow along with somebody on the screen rather than just reading the textbook. If it's helpful, please do give it a like and subscribe. Keep an eye out for any more videos I post. I do intend to make some more, so hopefully you're finding them useful. But let's get started on this one on trigonometry. I'm going to show you what you get in the formula book and how to adapt it to different questions. So let's get started. So here is what you get in the Edexcel formula book. You can see here this first three. These are the addition formulae, and you can quickly adapt them when A and B are the same. So you've just got A plus A. If B is A, you can quickly get the double angle formulae. You get the small angle approximations, and in the advanced information topic test, there's about 2 or 3 questions on small angle approximations, so I'll definitely do some questions on those. Differentiation, you don't get sine and cos, you just get these ones here, and then integration, you just get those ones there. So before we have a look at some actual past paper questions, I'm going to do an example of a cheat sheet. So you might want to make one of these for each of the topics. Just brainstorm everything you know and then look up other stuff that you think you might need for trigonometry questions and just have everything condensed onto one piece of paper. It doesn't need to be a work of art or take ages. Just have something that you've got next to you with your quick lookup sheet so that you don't have to be going into your notes all the time. So let's have a look at making one and see what we need for trigonometry. First of all, we might have a look at some identities. Tan x, you should know, is sine x over cos x. That's an identity, so we use the identity sign. Sine squared plus cos squared is always equal to 1 for any angle. Now this is actually a Pythagorean identity because we can use Pythagoras's theorem if we look at this unit circle here and call this angle theta, and you go along the x-axis and up the y to get a point xy. Now if we call it a unit circle so that the radius is 1, and you can make angles in all the quadrants all the way round. Now when we start making angles, when we turn anti-clockwise, that is positive. So we always start with going from the x-axis, 0, 90, 180, 270, 360. Now if we just look at this acute angle here in the first quadrant, it's in a right angle. We've gone x along, y up to get onto the circle. Now we wanted an expression for the opposite. Because it's in a right angle triangle, the opposite is equal to sine of the angle times the hypotenuse, and we're making that radius 1, so that's just going to be sine theta times 1, which is sine theta. Similarly, we can get an expression for the adjacent, and because in a right angle triangle, adjacent is cos of the angle times the hypotenuse, which again is 1, so that is cos theta. Now because we've made the radius 1, we can see that sine squared plus cos squared is equal to 1. We're just using that those expressions, and we're using Pythagoras' theorem. So that's why it's a Pythagorean identity. Now what we can do with that one that we've got there, if you think of all those things in that identity, all those terms, you can just divide through by cos squared. So just imagine cos squared underneath each of those. Sine squared over cos squared would give you tan squared. Cos squared over cos squared would give you 1, and 1 over cos squared would give you sec squared. So that's the other identity that you use. And then similarly, if you divide through by sine squared now, you will get 1 plus cos over sine, which is going to be cot, and then 1 over sine, which is going to be cosec. So that's the other one. So you can quickly derive them from the one that you should know. You should have learnt that maybe in lower 6 or at GCSE. So they're some of the identities that you're going to be using when you're proving identities. Now over here we've got the addition formulae from the formula sheet. Now you can quickly derive the double angle formulae. If you haven't committed them to memory yet, you can use what you get on the formula sheet. Where A and B are the same, so if we just say that they're all A's, and using the top one, sine of A plus A, which will be sine 2A, is equal to, when you've got A and B the same, you're going to get sine A cos A plus cos A sine A, so that's two of the same terms, so that's just 2 sine A cos A. Now doing the same with the cos 2A. Now notice the cos, it's the other way around. If it's plus there, it's minus there. So it's going to be cos squared A minus sine squared A. And now just rearranging this identity and substituting in that cos squared is 1 minus sine squared, you're going to get another expression for cos 2A, which is 1 minus 2 sine squared A, and then if we substitute for the sine squared, you get another expression for cos 2A, which is going to be 2 cos squared A minus 1. So you get 3 versions of cos 2A, and depending on what's in the question is which one you're going to use. Then tan, if we do A plus A on the top, we get plus there, but on the bottom it's minus. So tan 2A is going to be 2 tan A over 1 minus tan squared A. Okay, so they are your double angle formulae. Okay, let's look at some graphs. What I've got here, this is sine x in blue, cos x and tan x, but in green these are the reciprocals. So the green upside down sine is cosec, cos is sec x, and tan is cot x. Now how to remember which one's which? The third letter of the new function, the reciprocal function, is the first letter of the old. So that works. The third letter of the new is the first letter of the old. Third letter of the new is first letter of the old. Now there's also the arc sine, arc cos, and arc tan. So arc is the same as sine to the minus 1. Now to have an inverse function, the function has to be 1 to 1. So we have to restrict the domain. So we restrict it for the sine and tan between minus 90 and 90. So it's just a 1 to 1 function. Inverse functions are a reflection in the line y equals x. So arc sine is just going to reflect in the line y equals x. Arc cos, if we put that one in, is going to reflect over there. It's like a sort of moustache. And then arc tan, when we have our asymptotes going this way, when we're reflecting in a diagonal line, you are going to then get something like this. Is going to go the other way. It's going to be symmetrical a lot around that line y equals x. Now what else might we need? We might need our exact values that if you did Edexcel GCSE, you might have come across those and had to learn them. People have different ways of learning them. I like the 2 special triangles. So all I need to remember is that sine 30 is a half and sine is opposite over hypotenuse. So if that is 30, then the relationship between the opposite and the hypotenuse has to be in the ratio of a half. So if the opposite is 1, the hypotenuse would be 2. And then we can use Pythagoras' theorem. 2 squared is 4, take away 1 is 3. So this adjacent to the 30 would be root 3. And then because we've got 90 here, the other two angles must complement to 90. So that will have to be 60. So quickly just remembering that, a bit of Pythagoras and angles adding up to 180, you can get now the sine, cos and tan because you've got all the values of all the sides and all the angles. The other one to remember is that tan 45 is equal to 1. Now tan is opposite over adjacent, so we can put a 1 underneath, doesn't change the value of that. So if we've got 45 degrees, opposite over adjacent, and then Pythagoras again, 1 plus 1 is going to be 2. Square rooted is the hypotenuse, and then we've only got one angle in that triangle, but we can get the sine, cos and tan of 45. So hopefully all of these things will help us as we now look at some questions on trigonometry. So now let's have a look at working through some past exam questions, and these questions are taken from the exam board topic tests, which they say best align to the style and type of question in the exam. So this first one is proving an identity. So notice that we've got all that on the left and we're trying to get just tan theta. So theta is a single angle. So obviously because we've got all these double angles, we're going to be using our double angle formulae. If we look at the top, I don't want to get all these terms. I want to just reduce it down to sine over cos. So what I'm going to do is use the version of cos 2 theta, 1 minus, and then having here 1 minus 2 sine squared theta, because I can see the ones will cancel. So that's just replacing the cos 2 theta, and then plus the sine 2 theta. Well, that's 2 sine theta cos theta, and then all over. Now I would do the same on the bottom. It's going to be 1 plus, if I use the other version of cos 2 theta, which is 2 cos squared theta minus 1, when that plus goes into the brackets, the ones again are going to cancel, and then we've got sine 2 theta, so that's 2 sine theta cos theta. So I can see I'm going to cancel those ones. That's going to cancel. So I've got 2 sine squared theta plus 2 sine theta cos theta on the top. If I take out a 2 sine theta as a common factor, this minus and this minus is going to make a plus. If I take that out as a factor in that first term, you're just going to get sine theta and then plus cos theta. I do the same on the bottom, but this time take 2 cos theta out, then you'll have a cos theta plus a sine theta. And now all of that bracket, because it's times by that common factor on the front, can cancel with all of that because that's the same, and then we can cancel our 2's, and this is equal to sine theta over cos theta, which is equal to tan theta. So we've done it. Now notice in the next question it's hence solve, so that means we must use what we've just found in part A, and we can see that it's something very similar to what we've been dealing with in part A, but these 2's are all just replaced with the 4's. So because we've gone to double here, we can go to double here. So we can say that tan 2x is also equal to that expression, which they're now asking us to solve when it equals the 3 sine 2x. So we can just say that tan 2x is equal to 3 sine 2x. Now let's replace tan with sine over cos. So sine 2x over cos 2x is equal to 3 sine 2x. Now you might think you might be able to divide through by sine 2x, but don't divide when you get a situation like this. Like, keep it in because you'll lose one of your solutions. If I just cross multiply now, sine 2x is 3 sine 2x cos 2x, and then take that to the other side, I'll get 0 is equal to 3 sine 2x cos 2x minus sine 2x. And then if I take out sine 2x as a common factor, I will have 3 cos 2x minus 1 is equal to 0. Now, two things times together, either the sine 2x is equal to 0 or cos 2x is equal to a third. Now, where does the sine graph equal 0? 2x will have to equal 0. 180 degrees or 360. So x is going to equal 0, 90 degrees or 180 degrees. So because we were trying to find x in the range from 0 to 180, we could go all the way to 360 when we were doubling, and now if we're looking at this range, x has to be bigger than 0 and less than 180, so that's going to rule out those two, so x is only going to be 90 degrees for the solution for the first term. And then this one, 2x is going to be inverse cos of a third, which on your calculator is 70.5, and then using your cos graph or your cast diagram, that will be here, and then we come back from 360, 70.5, and that comes to 289.5, and then dividing by 2 will bring us two answers that are in line with our range. So x is going to be to one decimal place 35.3 and 144.8. Now, this next question is parametric equations, because in the advanced information it says use of trigonometric functions. So this is what we're doing here. Now, before we start the question, if we just have a little look at the three graphs, sine, cos, and tan. Now, you might not have seen this, but there is a thing called the cast diagram, which actually shows you and tells you which of these ratios are positive in which quadrant. So we start here with 0. When we go anti-clockwise, that is positive turn, so that's 90 by the time we get there, 180, 270, 360. Now, in the first 90 degrees of these graphs, the sine graph is positive here, the cos graph is positive, and the tan graph is positive. So that A stands for the all positive in the first 90 degrees. Once you get between 90 and 180, it's just the sine graph that's positive, cos graph's gone underneath, tan graph, so S stands for sine. From 180 to 270, it's the tan graph that is now positive, and then the last quadrant, the cos graph is positive. So that's going to be useful in this question, because we've got these two parametric equations. We need to solve and find where the curve, which is given parametrically, meets the circle x squared plus y squared equals 66. We can see it's going to meet in 4 different places, but we want just that particular one there, S. So all we need to do is square the x, square the y, and substitute them into the circle. So then the circle will be 100 cos squared t plus 4 squared 16 root 2 squared 2, 16 times 2, 32 sine squared t is equal to 66. Then if I replace the cos squared with 1 minus sine squared t, and then tidy up, I'm going to get minus 100 plus 32, and I'm also going to get plus 100. So if I bring the 66 over this side, I'm going to get 100 minus 66, which is 34. And here I'm going to get minus 100 sine squared t plus 32, but take both those on the other side. I'm going to get 68 sine squared t on that side. So just dividing, I'm going to get a half is equal to sine squared t. So sine t, taking the square root, and when you take the square root it needs to be plus or minus 1 over root 2. Now if you remember those special triangles before when we had 45, 1 and 1 and root 2, the sine of 45 is 1 over root 2, but that's just the acute angle. Now that would give us here the 45, and then we'd come back from 180 and that would be 135, but because it can be plus or minus, we're going to go into this quadrant as well. Now we are in radians. Whenever you're doing parametric equations or any calculus, you need to be in radians. So 45 is going to be pi by 4, and then the next one, it's not a whole pi, it's quarter of pi back, so that's 3/4 pi. And then it's 45 on from pi, so that's going to be 5 pi by 4. And then it's 45 back from 2 pi, or 360, so that will be 7 pi by 4. So that's going to describe all these 4 quadrants. Now to find S needs to be where we've got here x is positive, and here's the x given parametrically, and we need a positive. So cos of pi by 4 is going to be positive because that is this one here, but the other positive one is going to be this one, which is the 7 pi by 4. So both of those angles will make the x positive. Now which one of those will make the y negative? Because y needs to be negative to be in that 4th quadrant. So it's going to be this one here, 7 pi by 4. So t at S, t is equal to 7 pi by 4. So all we need to do is plug that into our parametrics. So x is equal to 10 cos 7 pi by 4, and y is equal to 4 root 2 sine 7 pi by 4. So we know that cos of 7 pi by 4 is 1 over root 2, so this will be 10 over root 2, which if we just rationalize the denominator, this will be 10 root 2 over 2, which is 5 root 2. And then y will be, well, sine of 7 pi by 4 is our minus 1 over root 2. So it'll be minus 4 root 2 over root 2. The root 2's will cancel. Y is minus 4. So the coordinates of S are 5 root 2 minus 4. In the advanced information, it does say trigonometric functions and area under curves. So this is an example of that type of question. We've got this curve given with the parametric equations in terms of t. So we know that P is a point on the curve that is A4, so the y coordinate is 4. So we're being asked to find the x coordinate. So first of all, we'll need to find what t is when y is 4. So in the y equation, if y is 4, 4 is equal to 2 sec t. So 2 is equal to sec t. So half is equal to cos t. Now either on your calculators or or your special triangles, sine 30 is a half. So that's 60 by Pythagoras, that is root 3. But the opposite for sine is actually the adjacent for cos. So inverse cos a half, t is going to be 60, which in terms of radians is going to be pi by 3. Now we don't need to find any other solutions because t is in the range 0 to pi by 2. So we've found our t. So now all we need to do is say what is x when t is pi by 3. So x is going to equal 3 times pi by 3 sine of pi by 3. So sine 60 is going to be the opposite root 3 over 2. So x is equal to, these 3's will cancel, pi times root 3 over 2. So you might just write that as root 3 over 2 pi. So that is going to be what a is. Root 3 over 2 pi. Okay, now let's have a look at the next part, B. The region is enclosed with the line x equals a, and we've got to show that the area is given by this integral here. So when you do an integration to find the area under the curve, you need to integrate y with respect of x. But because we're given in terms of our parametric equations, what we can do is integrate in terms of y given in terms of t, and then we must multiply by dx by dt, because then these will have the effect of being cancelled. Even though they're not fractions, they can operate like fractions, and because we've got that differential there, it will stand for those dt's cancelling. So really we are doing with respect to x. So we can have our limits in terms of t and just put all those bits together. So what we need to do is say when x is equal to 0, what is t equal to? Well, in our parametric equation, that's only going to happen when t is equal to 0. When x is equal to a, which is our root 3 over 2 pi, well, what t has just given us that answer, t was pi by 3. So that's sorted out these limits here in the question. Now we just need to do the y times the dx by dt. So we're going to be integrating between 0 and pi by 3 of y, which is 2 sec t. So I'm going to write that as 2 over cos t times the differential of x. So dx by dt is equal to, now this is a product, so we need to use the product rule. It's 3t first, differential of second, cos t plus second, differential of first, which is 3 sine t. So that needs to go in here. 3t cos t plus 3 sine t, and then we can integrate with respect to t. So that term on the front needs to multiply by both of these. So we can see in the first term the coses are going to cancel, and we're just going to get 6t plus, and then in the second one, when we multiply that in, the 2 times the 3 is going to give us 6, and the sine over cos is going to give us tan t, and that is between 0 and pi by 3. So this, just taking a 6 out, is going to be the same as 6 on the front, t plus tan t, which is what we want. Then part C, we've actually got to do that integration. So you get what the integral is of tan t on the formula sheet. So this is just going to be 6 on the outside. Integrating t will be t squared over 2, and integrating tan from your formula sheet is the ln of sec t, and we need to go from 0 to pi by 3. Just realised I've got those the wrong way round from what it actually wanted, but it's the same thing, isn't it? Because they're just adding. And then we need to keep the 6 on the outside and put in our limits. Pi by 3 squared will be pi squared over 9. Now when we divide by 2, that's the same as times it by a half, so it will actually be pi squared over 18 plus the ln of sec pi by 3. So sec pi by 3 is 1 over cos pi by 3. So that's going to be cos pi by 3 is a half, and then upside down that will be the ln of 2. And then when we put the other limit in, it's going to be 0. When you take that 6 in, it's just going to be pi squared over 3 plus 6, the ln of 2. In this next question, we're going to use the formulae for area of sector, which is half r squared theta, and arc length, which is r theta, and you must have theta in radians to apply those formulae. So we've got this diagram of the logo. It's telling us we've got this larger sector, two smaller sectors, and the two smaller sectors are congruent. So congruent means they are the same shape. And we're also told that AOF is a straight line. So angles on a straight line are going to be 180 degrees, but in terms of radians, that's pi. Now, because the two smaller sectors are congruent, these two angles here are going to be the same. So it's asking us in part A to write down in terms of theta the angle AOB. So we want the angle AOB. We just want that angle there. Now, when it says write down, that's exam speak for you can and should be able to just write it down. It shouldn't take too much work, and it's only worth 1 mark. So when the instruction in the question says state or write down, you're not going to be doing much work, and they're usually just worth 1 mark. So if the whole of the straight line is going to be pi and we take away theta in the middle, that will equate to both of the angles in the sectors. So we just need to share it equally and divide by 2. In part B, we've got to show that the logo is this expression, and that is 3 theta in the brackets. So this larger sector is going to be half r squared, and r for the larger one is worth 2r. So it's 2r all squared, and the angle's theta. For the smaller one, it's half. The radius is r, but the theta is the thing we've just worked out. Pi minus theta all over 2. So we've just got to have 2 of them. So all of that expression, if we times it by 2, we can cancel with the half on the front, and we just need to add those 2 expressions together. So the area will be half. Now 2r all squared will be 4r squared theta plus r squared, and then that bracket, because the numerator is all divided by 2, I'll just split it up and say pi divided by 2 minus theta divided by 2. So look where I need to go. I need to have half r squared out on the front. So I'm going to not tidy this up because I want to keep the half r squared out as a factor. And then multiply this in, it's going to be half r squared pi minus half r squared theta. Now I can take my half r squared out as a common factor. I'll have 4 theta plus pi minus theta, which will be half r squared, 4 theta minus theta, 3 theta plus pi. Now if you did multiply those together and get 2r squared theta, then you'd just have to factorize and take half r squared and times by 2 again and get the 4. So that you could do that. So that's the answer to part B. Now part C, it's asking us for the perimeter. So the perimeter all the way around the outside, we can see we need an R and an R for that bottom bit. We just need this straight edge. Well, if that is R, then the straight edge that's part of the perimeter is R. So we need one the other side. So the perimeter is going to be 4R. And then we need an arc length here, which is just r theta, and the theta is pi minus theta all over 2, and we need 2 of them, so again we can cancel the 2's, and then the arc length for the top is just going to be r theta, and the r this time is the whole of the radius, so it's 2r theta. So it's 4r plus r times pi minus theta plus 2r theta. So let's tidy up. 4r plus r pi minus r theta plus 2r theta. So we've got 4r plus r pi, 2r theta minus an r theta is just plus r theta. It says in the advanced information a trig series. So here's a question about sequences involving a trig function. We've got t of n is equal to sine theta plus 180n, and you're asked to express what is t1 and t2 in terms of just sine theta. So t1 is going to be when n is 1, so that will be sine of theta plus one lot of 180, so that is going to be 180. Now if we think about the sine graph, and then say we had a theta, what is the sine of the theta, and then we add 180, it's going to be minus the sine of the theta. But you could do your addition formulae. This would be sine theta cos 180 plus cos theta sine 180. So using our sine and cos graph, then cos 180 is going to be minus 1, so that would be minus sine theta, but sine 180 is plus nothing. So T1 is just going to be minus sine theta. Now T2 is going to be sine of theta plus 360, because when n is 2, 2 lots of 180 is 360. So if you think about sine theta, and then if you go a further 360 along another whole period, that's just going to be the same as sine theta. So you could do your addition and expand it all, but we can see on the graphs it's just going to be minus sine theta and sine theta. So one topic we didn't look at earlier is harmonic form, when you're given an expression with sine and cos and you have to put it in terms of just one ratio. So they either give you to put it in terms of sine or put it in terms of cos. So notice that the coefficients of the given expression are, we've got 1 sine x and 2 cos x. So let's have a go at doing that. Sine x plus 2 cos x, and we need to put it in the form of r sine x plus alpha. Now what you need to do is use your addition formulae to expand that. So that's going to be equivalent to r. Now sine expands to sine x cos alpha plus, now there'll be two terms when you expand that sine. They both need to be times by r on the front. So I'm going to put the r in there, and we'll have cos x sine alpha. So we've got a 1 in front of the sine x, and what would be the coefficient of sine x? All the things that go with that. So we've got 1 is equal to r cos alpha. Doing the same with the cos. 2 in front of the cos on the left. What would be the coefficient on the right of cos? That would be r sine alpha. So 2 is equal to r sine alpha. So you get two equations and you've got two unknowns. We're going to solve them simultaneously. What you're going to do is square and add. So squaring both of the left-hand sides, you've got 1 squared plus 2 squared, and squaring and adding both of the right-hand sides, you'll have r squared cos squared alpha plus r squared sine squared alpha. So you're going to get that 5 is equal to r squared, and then taking out that as a factor, cos squared alpha plus sine squared alpha is 1. So we'll get that r is just equal to root 5. And then to find alpha, if you put them in the arrangement of sine over cos, so you do the same on the left, 2 over 1 will equal r sine alpha over r cos alpha. The r's will cancel, and we'll get that 2 is equal to tan alpha. So with your calculator in radians, inverse tan of 2, alpha comes out to be 1.107. So if we go back and write our equation, our sine x plus 2 cos x is the same as root 5 sine of the x plus the 1.107. Now in part B, we're going to be using this given equation because it's similar to what's being used to model the temperature inside a room. The temperature, theta degrees C, is 5 plus 1 sine of this angle plus 2 cos of the same angle. So that's of the form that we've just been looking at, apart from x is all of this angle there and there. So we can say that this theta, the temperature, is being modelled by 5 plus, now how did we rearrange all of this in terms of our harmonic form? It was root 5 sine of, instead of x, we've now got all of that angle, so that's going to be pi t over 12 minus 3, and then add on our alpha. So that is the equivalent equation just in our harmonic form, and we're going to use that to deduce the maximum temperature, because when we've got it just in the 1 ratio, this equation is now governed in terms of its max and min by this sine function. The 5 and the root 5 are constants, so when does sine have a max? If you just look at the sine graph, the sine graph has a max at 1 when the angle is pi by 2. So this part of the equation that's modelling the temperature, the max it can be is 1. So theta's max is going to be 5 plus root 5 times 1. Can't go any higher than that, and that will be the max degrees C. Now part C, we need to find the time of day when this max occurs. Well, it's going to occur when the angle inside the bracket that we're taking the sine of is going to be where the max happens at pi by 2. So we just need to let pi times t over 12 minus 3 plus 1.107 equal pi by 2. Now if you solve that, put the 1.107 to the other side as a minus, add 3 on, times by 12, divide by pi, t comes out to be 13.23. Now what is t? T is the number of hours after midnight. Now we've got the hours as a decimal, so if you take 0.23 of 60 to get it in how many minutes, this is 13 hours and 13.8 minutes, which is really 13 hours and 14 minutes. And what is t? It's the hours after midnight. So if you go 13 hours and 14 minutes after midnight, that's actually going to be 1:14 p.m. So we've done it. So in this next question, we're going to use our small angle approximations. We're told theta is small. So when theta is small, sine theta is approximately equal to theta. tan theta is approximately equal to theta, and cos theta is approximately equal to 1 minus theta squared over 2. So when the angle is small, it's just the angle. So we've got here that theta is small, we've got sine of theta over 2 is just going to be the whole of that angle, theta over 2. So it's going to be 4 times theta over 2 plus 3. What does cos go to? 1 minus theta squared over 2, but we are squaring it, so we've got to square that. So then we'll cancel here and we'll get 2 theta plus 3. Now if we do 1 minus theta squared over 2 and times that bracket out, we're going to get 2 theta plus 3, and then we're going to get 1, and then minus a half theta squared minus another half theta squared is minus a whole theta squared, and then you'd also get plus theta to the 4 over 4. But when theta is small, raising it to the power 4 is just going to be negligible, and it wants us to approximate it just to the terms up to the squared term. So you're going to ignore that term there. So you'll get 2 theta plus 3 minus 3 theta squared plus, and the other terms will just be negligible. So this is going to be approximately equal to RA, which is 3, RB theta, which is 2 theta, and then minus 3 theta squared. Well done. If you're still with me by the end of this video on trigonometry, you've got through all those questions, so well done. Do bear in mind that these are only my walkthrough solutions. If you're looking at mark schemes, there'll be alternative ways to get answers. So hopefully you found this useful. Please do like and subscribe. Keep an eye out for any more videos I post, and I will see you on the next one.